Hi, my name is Claudia Kemp, and this is my written exam Zoom presentation report. Report is the word. So, number one is to complete two different puzzles. It's part A and part B. Now, for part A, it was a cross of circles that were to equal 31 across and down, and it gave me the numbers 8, 10, 11, 12, and 13. So, I did a guess and check method for this problem, and I found that the only way to solve it was to put 8 in the middle, but I came up with 4 different variations of the problem, putting 10 and 13 on the sides, and then 11 and 12 vertically, and then switching them around, making 2 different problems, and then making 11 and 12 the horizontal, and making 10 and 13 the vertical, and then again switching them around, making a total of 4 different possibilities. Then part B was a diagram that had circles in 4 corners, and then numbers in between those 4 circles, and then so the numbers in the circles were to equal the number added together were to equal the number in between the 2 circles. And so the first one had the number 7 in a circle, then 15, a blank circle, below that 20, a blank circle, next to that 17, and then a blank circle, and then above that 12, and then back to the 7. So I took 15 and subtracted from that 7 and got 8, and then the number below the 8 was 20, so I took 20 and subtracted 8 and got 12, and then from 12 I took the 17 next to it and subtracted 12 and got 5, so then 5 plus 7 equaled 12, and then the whole thing was correct. I did the same thing with the second diagram, and then I did the same thing with the fourth diagram. Now the third diagram did not have a solution. The numbers just did not work together no matter how many ways I tried, and there was no solution for the third diagram of part B of number 1. Number 2, 9 square tiles are laid out on a table so they make a solid pattern. Each tile must touch at least one other tile along an entire edge, and the squares all have side lengths of 1. So it said for A, to sketch all possible figures which can be formed and calculate the perimeters of each figures that can be formed. I was discovering, and it is my guess, that there is an infinite number of possibilities because I spent a lot of time finding different ones, and I never found an end to finding these figures. But I do know that in order to find the perimeter, one must take all of the outer edges of each square, so not ones that are touching another one, but the ones that aren't touching anything, and count those up going around the figure, and the number of those that there are equals the perimeter. So for this one right here, for instance, you would count all of these outer edges, and it would equal to 16. So that's how you found the perimeter. And then part B said which figure has the least perimeter and which is the greatest perimeter. The least perimeter is a 3 by 3, so 3 rows of 3 squares across comes the perimeter of 12, and then the greatest perimeter would be a 1 by 9, so 1 row of 9 across, and that would equal a perimeter of 20. Number 3 says show all possible solutions for the 2 following puzzles. So the first one is that you must always move up or to the right on the grid to move from A to B, and you're supposed to discover how many possible paths there are. So this is the diagram, and since A is here and B is here, and you can't go to the left, only to the right, you would this whole column right here is not included because it's to the left of A. But what you would do is you would use Pascal's triangle as your problem solving method here, and you would turn the graph so that A is at the top, and you would make that the top of the triangle. So it'd be 1 here, and then 1 and 1, and then the ones would go all the way down this row and all the way down this row. And so there'd be 1, 1, and 2. And then since there's 1 here and a 2 here, it'd be a 3 here and a 3 here, since there's 2 and 1 here. So then 1 and 3 made a 4, 3 and 3 make 6, 3 and 1 make 4, and then 4 and 6 make 10, 6 and 4 make 10, and 10 and 10 make 20. So then that makes B 20, meaning that there are 20 paths from A to B. The second one is a little more simple. It's just this diagram with lots of arrows. There are 4 different paths going from C to E. So 1 going here to here, 2 from here, here, and then here. 3 would be from here, and then to here. And then number 4 would be from C right here up and then to E. So that is how I solved number 3. Number 4 is an addition pyramid. So like this one right here. And so each number below equals the number above, kind of like Pascal's triangle. The two numbers below added together equal the number above. So the first one had 25 up top, and then 2 in the middle that were blank, and then X, 7, and 3. So I took 7 and 3, added them together, and made that 10. And then 25, I subtracted the 10, and that made 15. So 15 and 10 make the 25 on top. And so then I took the 7 that was under the 15 and subtracted that from the 15, making the X equal 8. So that filled the pyramid. The next pyramid, I did a guess and check method. It had 15 up top. The 2 middle ones were blank, and then it was 1, Y, and 2. So I just plugged in a few numbers until I finally got the correct answer, and the correct answer for Y is 6. 6 plus 1 equals 7. 6 plus 2 equals 8. 7 plus 8 equals 15. Then for letter C, I did the exact same thing, the guess and check, just plugged in a few numbers until I got the correct one. And it's 27, and then Z and 17 in the middle, and then 2, 8, and 9 at the bottom. Oh, I gave away one of my answers. All my answers, actually. So the 8 was blank. So it's 2 and 9, Z blank, and then 27. So I just plugged in 8 at the bottom, and it gave me 8 and 2 equals 10 for Z. 8 and 9 equals 17 for the blank next to it, and then obviously 10 plus 17 equals 27, therefore Z equals 10. Now number 5 is an eliminating possibilities sort of problem. 4 married couples belong to a bridge club. The wives' names are Kitty, Sarah, Josie, and Ann. Their husbands' names, in some order, are David, Will, Gus, and Floyd. Use the table below to sort out who is married to whom. So I made a table, this one right here, to sort out all of this information. So the first clue is that Floyd is Josie's brother. Since Floyd is Josie's brother, he obviously cannot be her husband, so that's an X for Floyd in Josie's column. And then Josie and Gus dated some, but then Gus met his present wife. So Josie and Gus are not married, so that is an X for Gus in Josie's column. Then it says Kitty is married to Will. So that's an answer that we needed. So that would mean that that's a circle or a check for Will in Kitty's column, and then an X for every other man in Kitty's column because she's not married to more than one man. So that also means that Will is no longer a possibility. So Will's row gets X's all the way across for Sarah, Josie, and Ann, since he's married to Kitty. Next, Ann has 2 brothers. So, anyways, Ann has 2 brothers, and that's just cool. But her husband is an only child. So this leaves David as Josie's husband and no longer a possibility, so he's not married to Sarah or Ann. And then it means that Ann's husband is Gus, and so he's no longer a possibility for Sarah, leaving Floyd to marry Sarah. And so it's just a matter of eliminating possibilities and taking clues and putting the pieces together. Number 6, consider the trapezoidal numbers 1 plus 1 plus 1 plus 2 plus etc. Now, letter A was create a dot pattern representation of the trapezoidal numbers. So 1 plus 1 plus 1, it would just be dot, dot, dot. And then 1 plus 2 plus 2 plus 2 plus 1. So we do a dot. And then you do 3 across of 2 dots, one on top of the other. So it'd be 1 dot and then 1, 2, 1, 2, 1, 2, and then another 1 at the end. And so then you would do the same for 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1. So the number represents how many dots are in that column, and then you just follow that along until the end of the problem. So that's how letter A was done. Then B, notice that 1 plus 1 plus 1 equals 1 times 3. 1 plus 2 plus 2 plus 2 plus 1 equals 2 times 4. 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1 equals 3 times 5. Show how the dots in a representation of a trapezoidal number excuse me, can be rearranged into a rectangle with 2 more columns than rows. So then you would take the number of dots that were in letter A for said problem, and rearrange them so that there are 2 more columns than there are rows. For 1 plus 2 plus 2 plus 2 plus 1, the number is 8. So you would make 4 columns and 2 rows there. So that is how that is done all the way across. And the answer to C, use inductive reasoning, show what general formula gives the nth trapezoidal number. So it would be n times n plus 2. So that is how that is found. And that is the end of my written exam. Thank you for watching. and I hope you enjoyed it.